In this video, I'm going to talk about how to find the general solution of a cosine equation. So I want you to notice, first of all, we have this equation, cosine x equals 0.8. And I want to solve this equation in the interval where x is between -7 and 13. And you can see on the graph that my left-hand value for my x-axis is -7 and my right is 13. So I want to find all the solutions that show on this graph. Now when I say solve cosine of x for 0.8, I want you to recall that we take cosine of an angle in order to find a trig value. And the angles are on the x-axis and the trig values are on the y-axis. In this case, I am in radians, so you can see over here it says radians. My x values are in radians, and my y value then is the 0.8. So I want to know what x value or values gives me a y value of 0.8. So I'm going to mark 0.8 on my y-axis, which is right here. And any place that has a y value of 0.8 could give me a potential solution. So if I go over to here on this right-hand side, I see that here is an x value down here that looks like around 0.6 or so that has a y value of 0.8. If I continue on across, I will find other values here and here that also have y values of 0.8. So far I've found 4 in the positive direction. If I go into the negative direction, I will also find another one here. And if I continue on across, 2 more here and here that all have y values of 0.8. So I'm actually looking for 1, 2, 3, 4, 5, 6, 7 different x values. So if I go straight down from each of these points, I will find an x value associated with each of these y values, and every y value is 0.8. Now, how do I go about finding all of these x values that all have y values of 0.8? Well, the first thing I'm going to do is solve the equation for x, and to do that I'm going to use inverse cosine. So x equals inverse cosine of 0.8. And if I do that on my calculator, I've already done this so it wouldn't take as much time, I find out that inverse cosine of 0.8 is 0.6435. And if I go back at my graph, that looks very reasonable, that this is 0.6435 on the x-axis. So x equals 0.6435. But how do I go about finding the other values? Well, one thing to notice would be to look at the symmetry of the graph. Here's the y-axis right here, and notice that the graph is symmetric on either side of the y-axis. So if 0.6435 is one x value that has a y value of 0.8, negative 0.6435 also should be another value. Looks like negative 0.6435. And to double check that, I'm going to go back to my calculator. When I say inverse cosine of 0.8 is equal to this number, that should mean that the cosine of this number is equal to 0.8. So if I put in cosine and go up and grab this number here, that should equal 0.8, which it does. Now let's try doing cosine of the opposite of that number. So if I put in a negative sign here and then go up and grab this number, inverse cosine of the negative of that number, it should also equal 0.8. So I am correct that both the positive and negative 0.6435 give me a y value of 0.8. So I can also write then that x equals negative 0.6435. So that is 2 of the solutions. Now how am I going to find the other solutions over on these other peaks here? This has to do with the period of the graph. If we look from high point to high point here, you'll notice that the high point's a little past 6. In fact, this high point is at 6.28 or 2 pi. One cycle of the graph has a period of 2 pi, and that's true for cosine and sine. In their original form, the basic parent function have a period of 2 pi. So every point, if I pick a point on one cycle, if I go to the identical point on the next cycle in the identical position, these points are 2 pi apart. So if I were to add 2 pi to this value of 0.6435, I would get the next value on this downward side of the curve. If I take the negative 0.6435 and add 2 pi to that, I would get the value on the upward side of the curve. And then I can continue and add another 2 pi. Oops, that's the wrong one. I'm going to take that off. If I were to add another 2 pi to the negative value, I would get the next point on the upward side of the curve. And I think I'm actually going to color the ones on the upward side of the curve red to differentiate them from the ones on the right-hand side of the curve, which I'll leave blue. If I wanted to find points on going the other way, I could subtract 2 pi from the original two values. So they're all 2 pi units apart. So doing this on the calculator, let's add 2 pi, and then we're going to add 2 pi again, and then let's subtract 2 pi, and let's see the values we get and see if those match up with what it looks like on the graph. So an easy way to do this on the calculator is to actually put both of the values in a set of curly brackets. If you do control parentheses, it opens curly brackets, and one of the values I want is inverse cosine of 0.8, and then I want negative inverse cosine of 0.8. And I'll go up and grab that again. That gives me my original two values, positive and negative. And then I can easily add 2 pi to both of them at the same time by doing plus 2 pi, adding it to the curly bracket, and then I get the next two numbers. So that gives me 2 more solutions. And then I'm going to add 2 pi again, plus 2 pi again, and that gives me 2 more solutions. So those are 2 more solutions when I add the values. And then I'm also going to take my original 2 values right here and subtract 2 pi from them. So minus 2 pi, and I think I did something weird here. Let me double check. Looks like, yep. So let me delete this. And go back. Sorry, I'm going to repeat this again. So go back up, grab this, and do minus 2 pi. So that would give me these values right here. I'm going to subtract 2 pi. I hit the wrong button instead of the pi, so let me get the pi. There we go. All right, so those are my 2 values. Notice that these numbers are opposites of these numbers, which we'll see on the graph in a minute. So here are some values. These are all my different solutions. So I'm going to write these down. And I actually may copy this and just put it in my document so we can see them over here. I'm going to put this down at the bottom of the sheet here. So I'll have this later on too as part of the notes. Oh, lovely, a little bit of technical difficulties here. There we go. All right. So writing these down, when we added 2 pi, what we got was 6.92669 and 5.63968. Those are the values that I see on the graph right here. If I go straight down from this point, that looks very reasonable for it to be 5.639. And when I go straight down from this value, that looks very reasonable to be 6.926. Then if I add 2 pi again, the numbers I got were 13.2099. Now that's not going to show because that's farther to the right. That's just a little bit beyond what the graph shows. So that one isn't going to be one of my solutions because it's bigger than 13. So I'm only looking for numbers in between -7 and 13. But my other solution is 11.9229, and that looks very reasonable for this one right here, 11.9229. And then the other two that I got when I subtracted 2 pi are -5.63968 and negative 6.92669. Notice those are opposites of the two numbers I got when I added 2 pi, and that makes sense because if I add 2 pi to these two numbers, I get this cycle. If I subtract 2 pi, I get this cycle. And using symmetry, they should be the same distance from the center as each other. So this is negative, so going straight down from here is negative 0.5639, and straight down from here is negative 6.926. I know those don't show very well. So I have a total of 7 solutions. I got these by starting with my original solution, taking the opposite of it because of symmetry, and then adding or subtracting 2 pi to get to additional solutions 1 period away or 2 periods away from the original solutions. So I can generalize that by saying if I know the value for y, this is my known value here, and I say cosine of x equals y, then x is equal to the inverse cosine of y, or negative inverse cosine of y, plus 2 pi n. Now the n means what I'm going to do is add or subtract 2 pi n times. Like up here, first of all, I didn't add 2 pi at all. That would be adding 2 pi 0 times. Here I added 2 pi 1 times. That would be n is 1. Then I added 2 pi again, so that would be n is 2. I've added 2 pi 2 times. Here I subtracted 2 pi, so that would be when n is negative 1. So n represents a positive or negative whole number or an integer. So this is n is an integer. And just to refresh you about what an integer is, that means it is a positive or negative whole number. The dot, 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 of course, means that these continue on. And it's the number of times the period is added to the first two solutions, which are opposites of each other. So opposites plus or minus 2 pi n. Now some of you may ask, do we always use 2 pi here? We always use 2 pi for the general solution when we're just talking about cosine of x. Now later on we're going to look at an equation in the next video where we have changed the period, the sinusoidal axis, the phase displacement, and so forth. And we will use this value while we solve, but our final solution will look different than this because the symmetry and the period will no longer be the same. But this is the general solution for just cosine of x equals y, and that will always have the 2 pi n in it. So let's use the general solution to solve cosine of x equals negative 0.6. So that's when y is negative 0.6, so I'm going to mark that on the graph. That's when we have these values here. And if we went back the other direction, so we see there's 6 different values where y is equal to 0.6. And it looks like around 2.2 and negative 2.2, or I'm sorry, 2.4, because those are by 0.2, about negative 2.4 and positive 2.4 are our first two solutions, and then the others will be 1 period away from that. So the first thing we're going to want to do is find inverse cosine of negative 0.06 and its opposite. So inverse cosine of negative 0.6 and negative inverse cosine of negative 0.6, and then we'll have plus 2 pi n. So I'm going to go ahead and write the actual numeric values for that. So on my calculator, I am going to open another page here and do inverse cosine. So once again, open the curly brackets and do inverse cosine of negative 0.6. Got too many negative signs in there, so let me back it up a little bit. Okay, so negative 0.6. Oh, I didn't do the curly bracket. There's the problem. So let me just start over. Okay, we'll just delete that. Okay. So curly bracket, inverse cosine of negative 0.6. Okay, then we'll put our comma here. And then negative inverse cosine of negative 0.6. Do Control Enter, and those are my first two values, which is about what I expected. I guess I put 2.4, it's about 2.2. And then I want to take those values and I'm going to be adding 2 pi in or subtracting 2 pi, or adding or subtracting 2 pi. But these would be my first two values when I'm not adding or subtracting 2 pi at all. So I'm going to write this down here. 2.2143 plus 2 pi n to negative 2.2143 plus 2 pi n. So my first two solutions are when n equals 0. In other words, if I substituted 0 in here, it means I'm not going to be adding 2 pi at all. So these are just my original two solutions, the first two that I see on either side of the y-axis. Then I'm going to add pi. So when I add pi, or I'm sorry, add 2 pi, so these are the first two solutions I got. These are my, I'm sorry, that's not my first two solutions. My first two solutions are on either side of the y-axis. This is the 2.214 and negative 2.214, which looks very reasonable. I draw those up there, okay? Now I'm going to be adding 2 pi, which will take these two solutions and it'll allow me to get the next two that are on this cycle here. So when n equals 1, I'm adding 2 pi. So going back to my calculator, I'm going to take what I have already and add 2 pi to this. And those are my next two solutions. And I'm going to go ahead and add 2 pi one more time because I will need another solution in addition to that. And I'm going to go ahead and subtract 2 pi also. So taking my original 2 and subtracting 2 pi. Okay. So this gets me all of my solutions now. There's my original 2. I added 2 pi once, so each of these are about 6 bigger than they were before. Then these are about 6 bigger than those. And then if I take my original 2 and subtract a little bit more than 6, then notice that these are both about 6 smaller than the original 2. So here are all my solutions. Once again, I'm going to grab these and just put them on here for reference. Grab this and kind of shrink it down. And grab that and shrink it down. So these two are here for reference, for notes purposes, if you want to see them. But notice when n is 1 then, and actually I could probably just mark these on here. This is when n equals 0. Here's when I added 2 pi once, so n was 1. Here's when n is 2. And here's when n is negative 1, because that's when I subtracted 2 pi, minus 2 pi. So notice the solutions that I see. These two are solutions I've already marked on the graph. The next two solutions I would mark would be these two, 4.06 and 8.49. So that looks very reasonable. Here's 4.06, 8.49. Those look very reasonable. The next solution is a little bigger than 10. It would be this one, 10.35. Notice that this one is too big. It's bigger than 13, so it doesn't fit in the interval that I'm looking at. Then on the left-hand side, my next one would be this one, negative 4.06. And the 8 is too small. It's less than 7, so that doesn't count. So my 6 solutions are these two, and these two, this one, and this one. And I got those by just adding and subtracting 2 pi to my two original positive and negative solutions. So when n is equal to 1, I'm adding 2 pi. When n is equal to 2, notice that means I'm adding 4 pi to the original two numbers. So I was adding 2 pi again. And when n was negative 1, that means I'm subtracting 2 pi. 2 pi times negative 1. So that is in general how you find, that's how you find the general solution of just inverse cosine. Now, we're probably not going to be solving too many equations that are just cosine, but you will be needing to know how to write this general solution. And once we have the general solution, we're going to be doing some other things to it to finish solving the problem, and then you will be able to need to generate solutions from the general solution. So this is the general solution for this particular equation. Cosine of x equals negative 0.6. The next video then will take this and apply this to a more complicated problem that has amplitude, period, phase displacement, and so forth changes.